function is defined as a relation between a set of inputs having one output each. In simple words, a function is a relationship between inputs, where each input is related to exactly one output. Every function has a domain, range, and codomain. Fun facts! Do you know that all functions are relations, but not all relations are function? In Cebuano, tanan function kay relation, pero dili tanan relasyon mo function. What is a relation? Relation defined as a simple correspondence between any two sets. In other words, a relation between two sets is a collection of ordered pairs containing one object from each set. Before we proceed, let us first unlock the terms that we are going to encounter throughout the discussion. First is the domain. Domain is a set of x coordinates. Second, the codomain. Codomain is a set of y coordinates. Lastly, the range. Range is the element of the set of y's that is used.
There are types of function. First is the injective function or a one-to-one function. A function in which one element of domain set is connected to codomain set, just like this example. Second is a surjective function or an onto function in which every element of codomain set has one pre-image, just like this one. And last is a many-to-one function in which implies two or more elements of the domain set with the single elements of the codomain set, just like this one. There are two conditions of a function. First, all elements of your domain must be used. And second, each element of your domain is assigned uniquely.
The positive and negative signs indicate that for every value of x, there corresponds two values of y. Therefore, y is not defined as a function of x. Function in graphical representation. A vertical line is drawn passing through the graph, and it must intersect the graph with one and only one point for it to be considered a function. Otherwise, it is just a graph of a relation. A function can have at most one y value corresponding to a given x value. Hence, the vertical line can intersect the graph in at most one point.
What is a set of ordered pairs? A set of ordered pairs is a pair of elements which occur in a particular order and are enclosed with brackets. So how can we determine if a set of ordered pairs is a function? We can say that a set of ordered pairs is a function only if an element of the domain does not repeat. If it repeats, then it is not a function. Let's take a look at these examples. Example number 1, which is a set containing 5 and 8, 7 and 6, 9 and 8. Let us focus on our abscissa or the domain. 5, 7, and 9 are our abscissa. So since none of the abscissa was repeated, we can say that this set of ordered pairs is a function, a one-to-one function. Example number 2 shows a set containing 5 and 8, 3 and 6, 5 and 7. The number 5, which belongs to the abscissa, was repeated. Therefore, this set of ordered pairs is not a function, an example of one-to-many.
Mapping. A mapping shows how the elements are paired. It's just like a flowchart for a function, showing input and output values. A mapping diagram consists of two parallel columns. The first column represents a domain of function f, while the second column is the range. If each input has one line connected to it, then the outputs are a function of the inputs. In other words, in mapping, you need to use all of the elements of a domain and assign it uniquely. Example number 1. First condition. All elements of your domain must be used. So we have only one element in our domain, and it is assigned to the elements of the codomain. So we have no problem with the first condition. Second condition. The elements of each element of your domain must be unique. Now, Jmar is assigned to Boss Joy. Jmar is assigned to Alastair. Jmar is assigned to Alexander. So it means it is violating the rule number 2. Therefore, it is not a function. Let us proceed to example number 2. Let us determine whether this assignment is a function or not. Let's say it is called G. It is clear that it is a rule or relation because we assign elements from domain A going to our codomain, which is B. So the question is it a function or not? First condition. All elements of your domain must be used. Let's consider A, I, and S. All of them are being used, so no problem with the first condition. Second condition. Each element of your domain is assigned uniquely. A is assigned to P only. I is assigned to P only. M is assigned to U only. S is assigned to F only. So we satisfy the second condition. So no problem with the first and second condition. So it is very clear that G is a function, a one-to-one function.
Tabular form. A table can be used to display functions as well. The function is shown in relation to the output and input in a function table, which is a visual table with columns and rows. Function machines and table are two terms for the same thing. Every function has an underlying rule that governs how the input and output are related.
So here we have the example f of x is equals to x plus 3. Now let us determine whether it is a function or not by using the tabular form. So here I have put the input, which is x is negative 2, negative 1, 0, positive 1, and positive 2. So what we're going to do is we are going to input the following x choices into each of the following given. So now we have x is equals to negative 2, so let us put negative 2 into the f, so we can determine that this is our x. So negative 2 plus 3, then we have positive 1. Next is negative 1 is our x. Now f of x is going to be f of negative 1. Let us put negative 1 here, so the answer will be positive 2. Next is x. Our x will be 0. So let us input x into our f of x, which is 0. Then we're going to put 0 here. The answer shall be positive 3. Next is, let us proceed to positive 1, which is our x. We have to input f of x into 1. Then let us put 1 here. The answer shall be 4, or positive 4. Lastly, we're going to input x is equals to 2, which is our final x input. Then we're going to put 2 here. Then the answer is 5. So now we are going to put it into our graph. After we have solved and put each of the input in the following given, we are now going to put our output here, which is negative 2. Is our input is negative 2, our output is positive 1. Our input for the next is negative 1, then our output is positive 2. Next is we're going to put in our tabular form the output of 0, which is 3. Next is the output of our input 1 is 4. Lastly is our input is 2 and our output is 5. Now that we are done finding each of the x and y values, let us proceed in plotting them in the graph. First, let us plot the negative 2x value and the positive 1 y value. So, here. Next, we're going to plot the negative 1x value and the positive 2y value. So, it is found in here. Next, let us plot the x value of 0 and the y value of positive 3. So it's here. Next, let us plot the positive 1x value and the positive 4y value. So it is found here. Lastly, let us plot the positive 2x value and the positive 5y value. So it is found here. Now that we are done plotting each of the x and y values, let us proceed in lining these plot points. So as you can see, this is a relation and it is also a function. Because every function is a relation, but not all relation is a function. Why it is a function? Because it has used all of the two conditions, which is first condition, all elements of your domain must be used, and the second condition is each of your elements of your domain is assigned unique. That is why it is a function and it is also a relation.
Graph. Graph is a set of all points in the plane of the form x and f of x. So, how can we determine if a graph is a function? We can determine if a graph is a function or not by using the vertical line test or pencil test. Vertical line is moved across the graph and at any time touches the graph at only one point, then the graph is a function.
If the vertical line touches the graph at more than one point, then the graph is not a function.
Equation. Equation is a mathematical statement that shows that two mathematical expressions are equal.
So for example, this one, y is equal to x cubed. The equation can only be function if the exponent of y is odd number. As you can see, the exponent of y here is an odd number. Therefore, this equation is a function. Well, this one, x squared plus y squared is equal to 4. As you can see, the exponent here is an even number. So therefore, this given is not a function.